So, pancreatic cancer is one of the deadliest cancers, and only about 1 in 10 people survive 5 years after diagnosis. And one reason pancreatic tumors are thought to be so deadly is because they're cold, meaning that they lack immune cells. So, this is the body's defense army that normally helps fight cancer. And without those cells, the cancer can grow unchecked. But we know that some pancreatic tumors do have immune cells, so we asked what makes the difference in survival if it's not just dependent on the presence of these cells. In many cancers, immune cells attack and kill the cancer cells, and that's why immunotherapy, or treatments that boost the immune system, have transformed care for cancers like melanoma and lung. But in pancreatic cancer, immunotherapy hasn't worked well. So we wondered if the answer lies in where the immune cells are inside the tumor and not just how many there are. And one reason we're looking at where they're located is because the immune system works like a team. So these cells don't fight alone, and they need to communicate and cooperate to launch an effective attack. But immune cells can only talk to each other if they're close enough to interact. And that's why their localization inside the tumor matters. So a scattered team can't win the game, but an organized one can. So we analyzed tumors from 73 patients with pancreatic cancer using advanced imaging and computer algorithms. And think of it like creating a map of each tumor. So we pinpoint the location of every immune cell and then saw how they clustered. And we looked at several immune cell types, but 3 became especially important. One was killer T cells, so the soldiers of the immune system, which can kill cancer cells. The next was helper T cells, or the coordinators. These are generals which organize and direct the attack. And then there were B cells, which help equip and activate T cells and support the fight. So when we looked at where these and how these immune cells grouped around the cancer, we found that patients with more helper T cells, or those coordinators, near the edges of the tumor lived longer. And these helper T cells often appeared alongside killer T cells and B cells, forming what we called a T cell neighborhood. So patients with more of this T cell neighborhood have had better survival, whereas other immune cell clusters didn't provide the same benefit. And our study shows 2 things. So the first is that pancreatic tumors aren't all the same. And the second is about when immune cells gather and interact in organized patterns, patients tend to do better. So understanding these patterns could help doctors predict survival outcomes and potentially identify who might respond to immunotherapy. So in short, mapping the body's defense army and understanding how its members work together could help turn a cold tumor into one the immune system can fight.